Hello, welcome back to this video. This is part 2 of 2-5. We're talking about the power rule, and in this video specifically, we're going to talk about how do you take the power rule when you are dealing with radicals. Now, before I go ahead and jump into this, I want to work backwards into the last video that we talked about. Example H, I forgot a negative here when you move it up, and so then that's going to go ahead and alternate this derivative, so that would be negative 12 over 2 times x to the power of negative 5, which gives you negative 6 over x to the power of 5. And if we go ahead and plug in 3, I believe by this time I've added an error note to the problem, but it would be negative 6 over 3 to the 5th, which gives you a negative, I believe it was 2 over 81, yep. 2 over 81. So my apologies on that. Okay, now that we've remedied that, I'm going to go back down to here. All right, working with radicals. Okay, now the deal with radicals is that whenever you're going to go ahead and take a derivative, you always want to turn the radical into power form. And what I mean by this is right here, that the square root of x can be written as x to the power of 1/2. And then additionally, f of x equals the nth root of x. That can be written as f of x is equal to x to the power of 1 over n. Okay, we're going to use this idea when we go ahead and look at these following examples. All right, example A. G of x is equal to the square root of x. Okay, so this is equal to x to the power of 1/2. So now I'm going to go ahead and I'm just going to use my power rule, and it's very, very simple. This is 1/2 x, and then I'm going to subtract 1 from 1/2, and I'm going to do this over here. 1/2 minus 1. This is equal to 1/2 minus 2 over 2, which is equal to negative 1/2. So negative 1/2. Okay, and if I wanted to go ahead and clean this up, this is 1 over 2 times x to the power of 1/2, which is 1 over 2 square root of x. And I'll let that sit and process for a second. I subtracted the power by 1. I used my negative exponent law. I moved it from my numerator back down to my denominator, and x to the power of 1/2 is now a radical. Now I do this because I know where we're going with this. They want us to compute g of 5, g prime of 5 also. So this is 1 over 2 times the square root of 5, and guess what? I'm done there. I could plug it into a calculator, I could get a decimal, but for all sakes and purposes, that is good. B. Okay. G is equal to negative 3 times x to the power of 1/2. And now I need to go ahead and find my derivative. Okay, so negative 3 times 1/2 is negative 3 over 2, x to the power of negative 1/2. And then I'm going to go ahead and clean this up. This is negative 3 over 2 times the square root of x. Again, I take this negative 1/2, I move it down into the denominator. That's why it's with the 2 now in the denominator. And then instead of writing 1/2, I write a square root of x. Okay, so there is that example, and then now I need g prime of 5. So I'm going to compute negative 3 over 2 times the square root of 5, and we're done. Pretty simple, pretty straightforward. All right, example C. Ooh, now I have a cubic root of x. So again, I'm just going to transform that radical into a power. So we have 5x to the power of 1/3, and then now I am ready to take a derivative. So g prime of x is equal to 5 times 1/3, so we get 5/3, x, and then I'm going to go ahead and subtract 1 from 1/3. So 1/3 minus 1, this gives us 1/3 minus 3/3, which is 2/3, negative 2/3, okay? And those become common, and you'll become much more fluent with them as we see these examples. Subtracting 1 from 1/3, subtracting 1 from 1/2, so on and so forth. Okay, And then I'm going to go ahead and I'm going to move this again into the denominator. So 5 over 3 times x to the power of negative 2/3. So again, this is a cubic root, and my numerator power is 2, right? And I just want to make sure that this is clear. X to the power of 2/3. The denominator is your root. The numerator is your power. Okay? So that's how we get g prime. Okay, now I'm going to compute and plug in 5. So we get 5 divided by 3 over the cubic root of 5 squared, which is 25. Done. All right, moving right along. I would like you to go ahead and try D on your own. Pause me. I'll show you the answer here in a moment. Okay, so the first thing that you had to do is go ahead and move that radical into the numerator. So that would be 4x to the power of negative 1/2. We'll now take the derivative. I'll multiply 4 times negative 1/2, which would be a negative 2x. And then I'm going to subtract 1 from the 1/2, subtracting 1, and that would have given us a negative 3/2. Okay, so last but not least, this is negative 2 over the square root of x cubed. Square root of x cubed. Okay. Yes. So I'll calculate g of 5, and we get negative 2 over the square root of 5 cubed, which is 125. There you go. All right, E. Oh, a 5th root. Now they're just getting crazy just to get crazy. But our approach is the same. This is 2x to the power of 1/5. And I'm going to go ahead and calculate my derivative. So g prime is equal to 2 times 1/5, which is just 2/5. X to the power of 1/5 minus 1. It's going to be negative 4/5. Okay, if you need to do that off to the side just to check and corroborate, you can go ahead and do that. And then I'm going to move this back to the denominator. So 2 over 5 times the 5th root of x to the power of 4. So now I can go ahead and plug in g prime of 5, which gives us 2 over 5 times the 5th root of 625. That's 5 to the power of 4. Okay, all right, now they're giving us 2 terms, right? Now they think they're being tricky, but they're not. I know that I can just take the derivative of one term at a time, but I just got to change it from radical form back into rational exponent form. So I have x to the power of 1/3 minus x to the power of negative 1/4. Okay, and so g prime of x is going to be equal to 1/3 x to the power of negative 2/3 minus 1 times the negative 1/4 gives us a positive. I was wondering how I was going to get out of that. X to the power of negative 5/4. I'm just subtracting 1. Okay. Again, making these exponents positive, we have 1 over 3 times the cubic root of x squared plus 1 over 4 times the 4th root of x to the power of 5. And then there's our g prime. Okay. The trick with these really is just identifying, okay, what's the denominator? Denominator 3, denominator 4, that's your root. Those are your roots. Okay, and then g prime of 5, I'm going to go ahead and evaluate at 5. So 1 over 3 times the cubic root of 25. That's a square, yes. Plus 1 over 4 times the 4th root of x to the 5th, 625 times 5. I don't have that one off the top of my head. 625 times 5. 3125. All right, so let's go ahead and look at these two. G and H are going to go ahead and be practice problems for you. So go ahead, I want you to try G and H. I'll show you the answers here in a moment. Okay, so for G and H, if we get this ready to go ahead and differentiate, we get x to the power of 3 over 2. So then G prime of x is going to be 3/2 x to the power of 1/2. I'm subtracting 1 there. So this is 3/2 square root of x. Okay, and if I'm computing this, G prime of 5 is equal to 3/2 times the square root of 5. Now you could, I guess, you could do this 3 root 5 over 2. There you go. And H. H, this is the same thing as 1/5 x to the power of 1/2. So G prime of x is equal to 1/10 x to the power of -1/2, which gives us 1 over 10 square root of x. Okay? G prime of 5, that would have given you 1 over 10 times the square root of 5. And there you go. At least in my class, you don't need to rationalize that radical in the denominator. That's completely fine to leave on the AP test. Now, just to refresh your memory on rationalization, multiply by the square root of 5, multiply by the square root of 5. You may see this answer pop up on a multiple choice portion of the AP test, but this would be 10 times, this gives us 5, so that would be 50, square root of 5 over 50, okay? All right, on I, I'm going to go ahead and, again, get this ready to differentiate. So I have -2x to the power of 1/2 plus 3. And I'm going to go ahead and use my power rule now to differentiate. So we get, looks like -2 times 1/2 is just a -1. X to the power of -1/2. Derivative of a constant is 0. And then, so this would be -1 over the square root of x. And then checking G prime of 5, we get -1 over the square root of 5. Okay? And again, you may see it, if it's rationalized, you may see it like this, -√5 over 5. Okay? For the most part, this is going to be fine. But multiple choice questions, you may see it like this. Okay. All right, last row here. Here's where we start to get weird and add in more terms. So G of x, this is 2 times x to the power of 3/5. And so I'm going to go ahead and differentiate this. G prime of x. Don't forget your notation, G prime. Make sure you write that. I'll multiply by 3/5. So 2 times 3 gives us 6 over 5. X to the power of -2/5. So I'll go ahead and clean this up. I'll move that x to the power of -2/5 into the denominator. That's the 5th root of x squared. So there's G prime. And then G prime of 5. So now I'm computing 6 over 5 times the 5th root of 25. There you go. Okay, and K and L. I'm going to go ahead and let you try this one. So K and L, go ahead and finish this up. Okay, hopefully you pause the videos. Here's what you should have gotten for K and L. You had to prep, again, I'm going to take this variable out of the denominator. So that's x to the power of -1. And then I'm going to change the radical to a fraction. So power 1/2 plus 5x. Okay, there's G of x. So G prime of x would have given you this, -1 x to the power of negative 2 minus 1/2 x to the power of negative 1/2 plus 5. And then simplifying, negative 1 over x squared minus 1 over 2 square root of x plus 5. Okay, and g prime of 5 would have given us negative 1 over 25 minus 1 over 2 root 5 plus 5. Here's g prime of 5. Pretty straightforward. Okay, and L. L, the trick is to just realize that this is a constant and that the derivative of a constant is 0. So g prime of x is 0. And thus g prime of 5 is 0. That's it. Okay, in order to summarize this video, whenever you have a radical, you're going to turn it into a power form. Take that square root of x and turn it into a power 1/2. Take the cubic root of x, turn it into a power of 1/3. And then you're just going to go ahead and use the power rule. That is it. I'll catch you in the next video.